Hi, I'm Charles, and welcome to part 26 of the OpenSCAD video series. In this part, we're going to be talking about list comprehensions, and what they are, and how to use them. So, let's get started. So, to start, the setup is a little bit different, I guess, from my usual videos. I've kind of pre-populated the programming file with a bunch of stuff, but the real meat of it, I'm gonna code for you here. It's just a lot of stuff to help us figure out essentially the output of what we're doing, and to make things a little bit easier so that it's a lot of repetitive coding just doesn't need to get done. And so we're going to talk about list comprehensions. And list comprehensions are essentially special operations in OpenSCAD in the context of lists to essentially populate lists. And so the sort of reference for that, if you wanted the main reference, which is in the documentation, would be at this link. So go check that out. If anything I've said is unclear, or if you need further information about it, this would definitely be like the main place to go if you wanted to learn a little bit more. But I will cover most of the sort of stuff that's going on. So let me get started. So a list comprehension is basically a convenient way to create a list of things. Probably a list of numbers, could be a list of strings, but in this case, I'm going to show you mostly, I think exclusively with numbers. So we're going to write a basic list comprehension. So essentially what that entails is we've got a function here, and the function's name is basic, and it takes an input A. Now A could be a string, or it could be a number, could be a whole bunch of things. In this case, we want A to be an integer. And I'm going to show you what that does. But something important to note that I'll probably hopefully mention again is that list comprehensions don't need to exist just in the context of a function. You can kind of just have them on their own, and I'll hopefully show you a little bit of what that means in a minute. But for now, I'm just going to show basic list comprehensions. So we make a for loop. We say I, our iterator, and we're going to say 0 through a minus 1. And that will, this essentially like gives us a for loop going like from 0 to a minus 1. So that gives us a values from 0 to a minus 1. So we'll just show what that is. So we'll just put the iterator here. So the format here is we've got this for loop here. So we've got the braces signifying that it is a list. We've got this for loop here. And then at the end, after the for loop, we have what it is that we want. So we want I, so we put I. So let me just show you what that does. A lot of this video is going to be stuff inside the terminal. So if we scroll up to the top here, so our this echo statement is used for essentially showing where we're at. So we take this function basic, we're at this part, basic list comprehension. It says basic list comprehension over here. Hopefully everybody can see that. And we called this function basic, and we called it with the input 10. And what that does is that creates a list of 0 to a minus 1, which would be 10. A is 10 in this case, so 10 minus 1, so it goes up to 9. And that's what we see here. We have 0 to 10 minus 1, which is 9. Another option for this, we could say 2 times I. You can put pretty much whatever expression you want here, as long as it involves the values that like we have that we're working with. So that's here. So 2 times the numbers that we're getting from 0 to 9 would be 0, 2, 4, 6, 8, to 18 essentially, and then, you know, whatever expression that you like. We could also have the square numbers. Yep, that gives us the square numbers, and we could change this to, you know, 15 if we like. So that's going to give us 15 values, etc., etc. So that's kind of how the basics work. That's the basics of a very basic description of a list comprehension. So now we're going to move on to something a little bit more. It's not super complicated. It's just like, let's say we have a list comprehension over here, and we have some complicated formula that we want to implement in the function, and we want a nice way to write that. So we have the let statement. So we're going to use the let statement. So I'm just going to move this down, make it a little bit more convenient to see. So we have our for loop. So it could be 0 through a minus 1, you know, or sorry, 0 through a minus 1, or it could be negative a through a minus 1. You know, you've got multiple options. I'll just keep it simple for now, 0 through a minus 1. That's a pretty standard for loop. And we're going to say let output equal, so we're assigning this variable output to what's going to be on the right side here, 2 times I minus 3i plus 4. So essentially we've made this quadratic equation here, and now we're going to say we want the output. So that's the whole thing. Essentially, we have our for loop over here, and we've got our square braces on either side. So we say we've got our square braces, we have our for loop over here, then we have our let statement, which allows us to assign variables. So we've assigned this variable output to what's over here. Sorry, that's going to give an error. And we have this quadratic function here. And then after all this, we say output, and so it should give us the output. So if we go along with that, we can see we're at let statement function 1, and see this is what we get. So we get these values over here. It makes sense, like it goes from 0 to 9 in this case, and we can see if on the first value I would be 0, so we would just get 4, and then I would be 1, so you'd get 2 minus 3, which is negative 1 plus 4, which is 3. So that makes sense, and then you follow the rest of the values, and that's how it works. So yeah, that is a basic let statement. I'll do a slightly more complicated let statement now. Same deal. We want a for loop. So for I equals 0 to a minus 1, just giving us 0 to a minus 1. We have another let statement. We'll say value is equal to I times I minus 20. So that's a cubic function. And we can say second value, and we can rearrange this because it's going to get a little messy. So this is the start of the list comprehension. This is the end of the list comprehension. We have our for loop. We have our let statement. Second value is equal to value times 2 plus about minus 43. Okay, and so if we don't want value as the output and like we have some complicated function to implement, we essentially can organize that all within this let statement. So we have value is defined here. Pretty sure we want them to be defined sequentially, so we define value first to include it in the next function. So now we can say we want the output second value, and that should give us something. So here's let statement function 2, which is over here, and it's we call it with an input of 10, so we want 10 values, and it gives us our output. Let's just confirm we've got 10 values. 1, 2, 3, 4, 6, 7, 8, 9, 10. That's correct. And the numbers are a bit complicated, so I don't know. I'm pretty confident that they're correct, but I can't just evaluate it off the top of my head. But that's what we have computers for, so that's why it's doing the hard work here. If we wanted like 2 values, that's fine. And we get our 2 values essentially. We probably could evaluate it if it was, if it's just like, if it's 0, if I is 0, this is 0, we get negative 20. And 2 times negative 20 is negative 40, minus 43 is, you know, negative 83. So that seems right. Okay, so that's basically how you do this with let statement. That's how you do list comprehensions with let statements, and they can be pretty useful, again, if you're making complicated functions. Okay, so the each statement I actually had a bit of trouble wrapping my head around, but it's a pretty useful, I could see how it's pretty useful. I don't think I've had a use case for it yet, but if you're doing complicated array manipulation and stuff like that, I can see how it would be useful. So one convenient way to do this, and here's an example of sort of list comprehension just being on its own without a function. We can type each, and what this will do is, let's say we want the numbers negative 10 to 10. So this is just a range. And if you output it, like if I just, let me give an example. If I just output this as it is, this is just a range. So that gives us, you know, this range, it's going from negative 10 to 10 by steps of 1. But that is different than having each value individually. So let's say we want each value expanded individually. We can type each and put that in the context of a list comprehension. Or we say we have our list, then we say each, and then we give our range. And that will expand all the values. And that is a quick way to populate a list of a range. Again, you could probably do this, you know, in increments of 2. So yeah, if you want a step list with an increment of 2 or whatever, this is a convenient way to do it. It's like a compact notation for it. And then you have a list to work with, as opposed to just going through each of the values in a for loop, because, you know, you can do some different things with those, because if you just go through things in a for loop, each value is kind of transient and only works once in the loop and doesn't really carry over. But in a list, you know, you can do a bit more manipulation. So yeah, there's that. Each statement. So here's a simple way to concatenate 2 vectors. You can have each. So first of all, we have vector 1, which is 1, 2, 3, 4, 5. Vector 2, 22, 33, 44, 45, 55, 66. And let's say we want to just put these into one list. And I'm pretty sure there is a concat function that does that. So that's a good way to do it, but here's just an example of a different way to do it. Each vector 1, I think each vector 2. Hopefully that does it. We have vex over here, and we're just printing it out over here. So, yep, this that's what happens. You essentially have this whole thing concatenated now. Like you just add them together. And then, so like, let's say you have something a bit longer or something multidimensional, like a matrix, like this, and it's got like subvectors. So this is like a vector of vectors. So we've got our outer list here, and then we have our inner lists. And you just want this whole thing in one big list. I'm pretty sure this is the example I'll give is in the documentation, but I'm just going to demonstrate how to do this. This works with 2 dimensions, but if you were working with higher dimensional tensors or something like that, it's probably a bit more complicated. I haven't worked with that in OpenSCAD so much. So how you would flatten this matrix or flatten any essentially 2D matrix is like this. You have your for loop, and you say v is equal to vec, and essentially what this does is this goes through each value in vec, which is the input. So in this case, v is going to become this, and then it's going to become this, and it's going to become this, and then we're going to want to do things with that. So there is another way to do this, but the way I'm going to show you here is just to use the each function. So essentially we just take the each vector, and then we apply each to it, and then it kind of just undoes the vector around it, and then just applies the values into the list itself. So let's see what happens here. We're flattening vectors with each, and we're going to flatten. We're using this function flatten to flatten this matrix called matrix. So let's see what happens. So flattening vectors with each 4, 5, 6, 1, 2, 3, 0, 6, 2. And that's essentially what it is. 0, 5, 6, 1, 2, 3, 0, 6, 2. And that, yeah, that could be useful. You could have a much larger matrix and have it do this. And something, that's also a bit convenient about OpenSCAD, or at least this format, is that it's not super fixed in place. So if I wanted to add 7, 8, 9, 100, 1090, I can do that, and it will just, it'll just kind of unpack that into the outer list, and that's pretty convenient. Just a useful way to work with lists. So, okay, now moving along a little bit, there's something pretty interesting that list comprehensions can do, which is kind of unusual for OpenSCAD, which is iteration. So really the only 2 ways to do proper non-functional iteration, I guess. I don't know if that makes any sense, but like with certain programming languages, they don't really allow you to have fixed values that you can change later on in particular ways. And OpenSCAD generally doesn't like that. But in this case, and in the case of recursion in OpenSCAD, you can get specific special manipulations that you can do. So I'm going to show you that. It has something similar to a C syntax. This is in the reference if you want to take a look at it as well, but it allows certain, just, iterating on values in particular ways. So we have our for loop, but we don't use normal OpenSCAD syntax in the for loop. So we say I equals 0. And so what this is right here is we're setting I to 0. So now it could be 0. We could also set it to -1. We could set it to 10. We could probably set it to, maybe I should check that this works. We should probably be able to set it to 1.5. And that's our beginning statement. So we have I equals 1.5. Now this is a stopping condition. This is essentially, once we pass this condition, the program will check it and say, okay, we're past this condition, we don't want to run the loop anymore. So we say I is less than A. And that says, like, we're gonna change some things later on. And if I becomes greater than A, that means we've finished the loop and we don't want to iterate anymore. So that is the next thing. Sorry, I'm just gonna move this down here so we've got a little bit more space. So I equals 1.5, I is less than A. Generally you want I to be an integer. I'll demonstrate that in a second again. I is less than A, and then here's where the iteration part comes in. So we can say I is equal to I plus 1. And this is our iteration part where we actually iterate on the value of I and we increment it. We could increment it by 2 or by 3 or 3.5. And so now we've got values. We can do let statements after this, like a normal one. But I'm just going to show it being super basic. I'm just going to show I. So what's going to happen here is we've got I is equal to 1.5. I is less than A. In this case, it's 50, so it should be. And then it's going to output I, which is 1.5. And then we're going to increment it after that. And we're going to get I is equal to I plus 3.5. So 1.5 plus 3.5 should be 5, I hope. That'd be really funny if my math was off there. And then it'll check if it's less than A. Again, in this case, it's 50. So should keep going, and then it'll keep outputting it. So let's just run that and see what happens. So we're looking for iterating function, and here we've got it. And so the first value is 1.5, and the next value is 5. Yeah, look at that. Good at math. And then it keeps going. It increments by 3.5, and then the final value is 47. Because once we get to 47, if we get to 47, we add 3.5, we get 50.5, and that is not less than 50. So we terminate the loop. So that is what's going on here with this iterating for loop. This might be a bit confusing if it's the first time you're seeing for loops. So let me just give a simpler example. Let's say I starts at 0. I is less than A. A is our variable again. And then we say I is equal to I plus 1. So this is just going to increment it by 1. And we should get the numbers from 1 to 50, not including 50. So iterating function. Yeah, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. all the way to 49, which doesn't include 50. And if we wanted to include 50 and make a bunch of computer scientists real mad, we can do a less than or equal to A. And we get 51 values, including 0 and 50. So that's, yeah, that's that. I think I'm going to leave it at less than, not to drive myself insane. So we got 0 to 49, and that's essentially what's happening here. It's a simple iterating for loop for list comprehensions, and I'm pretty sure that it can only really be done in list comprehensions in this way. We can even throw in like some extra values, like we could throw in A is equal to oh, sorry, not A. Let's say J as an extra iterator. Let's say J is equal to 0, and we want this conditional statement to be J is less than A as well. So let's say J is equal to, oh boy, okay, so it's just getting a little bit messy. Try and clean it up a little bit. And this is the output. So we want I is less than A, J is less than A. Let's say J is equal to 2 times J plus 1. And use example from before, I and J. So we're going to put I and J in there together. Hopefully this isn't too confusing. It's kind of just to serve a point. I think I'll change it back in a minute. Maybe I'll just copy and paste it. But it's to show that you can do a little bit more with iterating than just like a standard for loop. You can have like extra considerations in here, like extra variables and extra like more complicated conditions and extra iteration. And that can like change your values and stuff. It works. So 0, 0, 1, 2, 2, 6, 3, 14, and 4, 30. So these are like pairs of values that they start at, and we can see I just iterates by 1. It goes 0, 1, sorry for this kind of mess here, 2, 3, 4, just standard iteration, and J, our second variable, goes 0, 2, because it's J plus 1 times 2, so 0 plus 1 times 2 is 2. Then we get 2 plus 1 times 2 is 6. 6 plus 1 times 2 is 14, because that's 7 times 2, which is 14. And then 14 plus 1 times 2 is 30, so 14 plus 1 is 15, times 2 is 30. Then 30 plus 1 would be 31 times 2 is 62, and 62 would be greater than our value here. So we're calling this function iteration here, and we're calling it with a value of 50. So A is 50, and we're making sure that J is less than A. So after this value, J would have incremented past our constraint, and then this constraint is violated. So the loop terminates. And that's just something I wanted to show that you could do with this. So let me just copy and paste this. I want the simple one as well, because that's probably much more useful. I is less than A, I equals I plus 1, and we want I, so we'll call operation extra. And we essentially just want this one. So if we go back to this, make sure that it's working, iterating function, and we call it with 50, we should get the values from 0 to 49, which is what we get. Excellent. Okay, so I'll move on to the next one. So some things that we can do, you can put conditional statements in list comprehensions. And I'm going to show you how to do that. So we start off with our standard this comprehension. And if it gives it away, hopefully we're going to show how to create the even numbers, like a grouping of even numbers. So for I equals 0 through a minus 1, we're going to have our if condition. Looks like this. If I modulo 2, so this is the modulo operator, is equal to 0. So essentially, if it's an even number, or if it's divisible by 2, which those are equivalent, we want to output I. So essentially, we're saying we have our for loop, and again, this could be used with the iteration that we did earlier, but this is just the standard way to do it. So we have our for loop, and then we have our if condition, this whole thing here, and if the criteria is met, we output the value. We essentially add it to the list, and otherwise it's not added to the list. But there are things we can do. I'll show in a moment. So, let's see. Okay, we have the conditional function, and we're calling even numbers. We're calling even numbers here. And we're calling it up to 50. So we're saying if it's divisible by 2, we want that number. So we can see it goes 0, skipped over 1, goes to 2, skipped over 3, goes to 4. Now this isn't necessarily the most efficient way to create this list. It'd probably be better just to create the numbers from like 1 to 24 and multiply them by 2, because you're skipping over a bunch of numbers by going here, and that's kind of wasted compute. But this is just to like serve as an example. Like you can conditionally choose or reject things, because sometimes you have those anyway, and like you need to check them anyway. So like if you were going through another list of numbers and you wanted to reject values over or under some value, then you could just set set this to be that. That is probably a good example. I might do that. So yeah, we could change this to 3 to get the numbers divisible by 3. And so we get 0, 3, 6, 9, 12, the multiples of 3, essentially. Change that back to 2. So let me just copy this over. I'm going to make an extra example that I wasn't anticipating making. Let's see, filter. Okay, so we have our for loop. So we'll change this. We're going to assume that we're going to assume that the input is a vector instead. And so we change this to the length of the vector, -1. So we want to be able to index everything. So let's just say if vector I, so we're indexing vector at the ith element. Let's say it's less than some value, cutoff. If it's less than or equal to cutoff, we want to output, we want the value. And so here's an extra part, an else statement. Demonstrate an else statement. We want it to just be 0. So, okay, that didn't do anything. I'm surprised that it actually worked, and that's conditional function. So let's call this filter function, and we want this with a list. I don't know why that worked. That probably, oh, yeah, I know why that worked, because we didn't change the function. So let's change that. So now we've got filter numbers. It takes a vector and a cutoff value. So let's say that cutoff value is 5. And go 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. Maybe it actually makes more sense to say we want to output the cutoff. So essentially what this is supposed to do is we're going to take this list of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1, and we don't want any numbers greater than 5, greater than the cutoff we've provided. So we're going to go through them all, like essentially we're going to iterate. We're going to have a number that iterates through the length of the vector. We're going to index each thing. We want it to be either less than or equal to the cutoff. Sorry, that would be bad. We don't want that. We want this. We want it. Okay, that's extra. We want the element to be less than the cutoff, and if it is, we output that element, and if it's not, we output the cutoff. So essentially we cap it out, or clip the values. So let's see what happens here with filter function. So as we expect, we get 1, 2, 3, 4, as we have here, 1, 2, 3, 4. We get to 5, and then anything bigger than 5, between 6, 7, 8, 7, 6, they all get converted into 5s, and then we go 4, 3, 2, 1, which is what we want. And we could change this cutoff value from 5 to, let's say, 7. So now only the 8 in the middle is cut off, and that's how you can use the filter function, or not the filter function. That's how you can use list comprehensions to filter values in a list. So now there's another conditional statement that we could have. We can have an else if, and that can be like, that just divides up the things that we can do even more. So let's say we're gonna create a for loop over here. Keep it simple. I is equal to 0 through a minus 1. So let's have our first if statement. If it's divisible by 4, maybe by 5. Let's say if I is divisible by 5, we want to just output I as is. Okay, so maybe that's okay for some circumstances, but not okay for all of them. Let's say else if it's divisible by 2. We want, so if our iterator is divisible by 2, we want that as a negative number. We want negative I. And if it's none of these things, so if it's just a number, it's not divisible by 5, it's not divisible by 2, maybe we just want 10 times, maybe 100 times that number. So 100 times I. So if it's divisible by 5, like 5, 10, 15, 20, we're just going to output the number. If it is divisible by 2, although this is the first statement, so this one takes priority, then we go to this one if this one doesn't apply. Because 10 is divisible by 2, but it's divisible by 5 first. So it's just going to output 10. But 8, which is not divisible by 5, which is divisible by 2, we should get -8. And then for every other number, like 3, which is not divisible by 5 and not divisible by 2, we should multiply it by 100, and so we should get 300. So let's see what happens. And again, we've got the else if function, and we're running that with an input value of 50. Yeah, let's see what happens. So let's go. Okay, so 0 modulo 5 should probably be 0. And it's just output as it is. I mean, the negative value, let's forget 0 for now. So 100, is it divisible by 5? No. Is it divisible by 2? No. So we go to 100 times 1, which is 100. So 2 is not divisible by 5, but is divisible by 2. So we get -2, which is what's happening here. 3, we know, we talked about not divisible by 5, not divisible by 2. We're getting 100 times 3, so we get 300. 4 is divisible by 2. 5 is divisible by 5, so we get the value for 5, and for 4 we get the negative value, etc., etc. And that's how you can kind of like do different things with inputs. So this could have been a vector as well, and then we're just, filtering in a different way. Like we want some values and we don't want others. So yeah, okay, so that's essentially the conditional if, else if, and else functionality in list comprehensions. So, okay, now this is probably where I found the most use, outputting vectors from list comprehensions. So the outputs so far have just been single numbers, essentially, except, each condition is a little strange, but at the end of the day, we were just getting numbers out. But we can get other things out, like vectors. So that's actually a pretty useful functionality of list comprehensions. You can, and it's going to be useful later on. We are going to create a bunch of points using list comprehensions. It's a convenient way to make points and allows us to work with things that regular for loops wouldn't allow us to do easily. This makes it easier, essentially. So let's take this down here. So we have, okay, I don't know why that's so far out. Okay, so our for loop, so we're going from 0 to a-1 as usual. Just gonna go all the way out there. No, okay, we're good. Okay, so we've got our for loop. This is pretty straightforward. So after our for loop, like our final thing, we can just output a vector. So we can say I times I, so we want I squared, and I times I, so I cubed. So essentially what we're saying is we've got our for loop, and then we've got a vector. So this will output a vector of 3 values, I squared, and I cubed. And let me just show you. So we've got vectors, which is this function vectors, and we're calling it with a value of 10. So a is 10, so this is going to go from 0 to 9, and so we'll get I squared, I cubed from 0 to 9 in vector format. So here we go, vectors function, that's where we're at, and for I equals 0, 0, 0, 0, then 1, then 2, then 3, and so 3 3 squared is 9, 3 cubed is 27, etc., etc. And we get all these things as vectors, and we can index into them. So like, let's say we wanted this. Okay. So we could assign this to a value. The vectors equals vectors 10. So essentially we're assigning this value to be the output of this function, which is this. Maybe I can even demonstrate that. It should be exactly the same. So we want a specific value from it. We can index into it. So this should be at index 9 if we want the last one. So we have this first output, we're outputting this first one, then we're outputting this second one here, which is the output of this, and then we are indexing into it. So we index into this, essentially, and we get the last one. So we take the thing at the 9th index, which is this last item, and then we can index into that again if we want the middle item of that, like the square item. Whoops, I forgot semicolons. If we want the middle index, the first index, this value 81 here. So, whoops, nope. That's my mistake. So we need to index first into the big one, and we take the last one, and then we get the value here, like the middle value 81. So let's try that again. Yeah, so we've indexed into the last value of the original list comprehension, which is a list itself. So we get that list, and then we index into that, and we get 81. And that's what's going on. Okay, so that is, this one feels a little bit messy, so I'm just gonna clean that up like that. The next thing, well, there's quite a few topics, I guess. We have multiple for loops for list comprehensions. Like, you can do more than one for loop in a list comprehension, like nested loops. So I think you might be able to do this in 2 ways. I can just double check. Let's say I equals 0 through a minus 1. J is equal to J is equal to 0 through a minus 1. And we'll put a vector to make this pretty clear. We'll go ij. So essentially we're saying I goes through the values from 0 to a minus 1, j goes through the values from 0 to a minus 1, and we're outputting the vector ij, and we'll see what happens. So here's the multi-loop function, which is this one. And as you can see what's happening, we start with 0, then j iterates, and it keeps iterating, and we called it with a value of 6, so a minus 1 is 5, so it goes up to 5 here, and then I increments, and goes along from there. So maybe I could even call this with something smaller to make it a little less complicated. So yeah, you can see if I call it with 3, j goes up to 2, then I increments, but j is like the sub loop, so it increments on each increment, while I only increments like every time j has completed the loop. So I'm pretty sure you might be able to even separate these. And that gives the same output. It does give the same output. So you can have like these two different distinct for loops like this, or you can have them joined by a comma, and that does the same thing. So that's convenient. In the next case, I'm going to show a multi-iteration list comprehension. So we're doing something similar to what we had up here, where we have multiple for loops, but we're going to do value iteration, like where the values are actually, we control the iteration as opposed to just assigning stuff to a range. So we're going to have these two for loops. We say I is equal to 0, I is less than a, I equals I plus 1, and j is equal to 0, j is less than a, j equals j plus 2. And we'll just do something very similar to what we did before. We'll say ij, just output this vector. And this is a good way to actually give us a two-dimensional grid of values. So let's say you wanted a 2D grid of values that you wanted to do stuff on, like you wanted to take the values and do something. Like if we wanted to enumerate the values on the XY plane here, this could be a good way to do it. So yeah, let's just see what this does. So we see that j iterates by 2 every time. So it goes 0, 2, 4, until it's less than, the condition is that it's less than 6 because we're calling multi-iteration with a value of 6. So it goes 0, 2, 4, then it would be 6, so we don't want that, so the iteration terminates, and then we iterate I goes to 1, and then j keeps iterating, etc., etc. And that's a multi-iteration for loop in a list comprehension. So yeah, that is that. Yeah, and you can change the conditionals again. We could say we want this to be less than 2 times a, and we get this. So j goes up to 10 because 12 would be too big, etc., etc. And then it iterates. Hopefully that's not too confusing. I'll just take this back down to keep it simple. Okay, so a function in a list comprehension. So like we have list comprehensions up here, maybe we have functions that we've already written, and we're actually going to use this in a moment to create functions, or create list comprehensions using functions if we wanted something a little bit more complicated. So let's say we have a function, we have x over 2 plus 1 divided by the absolute value of x plus 1. So this is the function, and we want values that are related to this function. And so let's do that. Maybe let's take I is equal to negative a this time to positive a. And so there are like 2 reasonable ways to do this. We could say let me take this down for a sec. let output equal my function I, and then we want to just output. Maybe this is a bit confusing. So we've got our square braces for our list comprehension. We have our for loop in the list comprehension. We have our let statement, where we assign output to be my function, which is the function that we've defined over here. And we input I. So our iterator here that we've created, we input that into the function. And then we assign the output of that to output. And then we make that output. Funnily enough, you could have my function be a function that returns a list, or a list made by a list comprehension, and then you could put that in a new list comprehension, but that is kind of complicated. I don't know if that might be a bit too complicated. So we have the output of my function, which is just a number, goes to output, and then we return output. So you can say function comprehension. It's this one over here, and it is like, it's kind of, you know, we don't necessarily know if the values are right here. Maybe if it's 0 or 1, so like if I is 0 or 1, if I is 0, x over 2 is 0, plus 1 over 0 plus 1 is 1, so it actually shouldn't be 0, so it's probably like this one or that one. Yeah, and if it's -1, we have -1 over 2 plus 1 over absolute value of -1, which is 1, plus 1 is 2, so 1 over 2, so -1 over 2 plus 1 over 2 is probably 0. So if I is -1, then the output should be 0. So looks okay. Another way to do this is we could just, instead of having this whole let function here, let's copy and paste this. We'll call this original. So we can just get rid of this and that and that. Like, we don't need the let statement. It just makes things cleaner if you have more functions that you're using, or more valuable variables that you're assigning. So let's say, so now it's not going to evaluate this one because we're calling flist. So flist is this function. And we get the same thing, which is great. Okay, so now to actually getting to use them. Like, what do we actually use these things for? And so let's say we wanted to create a spiral. That is something that we're going to do right now. So okay, let me just do that. Okay, so we have a spiral, and a spiral, we're now going to switch over to the viewing part to see what's actually going on. So a spiral with height, like a coil, like a spring. So it's got a height, it's got a radius, it's got a certain number of rotations, like how many times the coil goes around. And in our case, because it's discrete, we have a certain number of steps. So how many instances, like how many points do we want in this spiral, essentially? Like, do we want like 20 points? Do we want 100 points or 1,000 points or something like that? 1,000 usually looks better, but is probably harder to render. So in general, you want this to be able to be tunable. So what we're going to do, we actually start with steps. So we say I is equal to 0. through steps minus 1. So essentially this is going to give us a range from 0 to steps minus 1. And we actually want a vector output. So we have a vector. So now essentially what we want, we have some formulas that you might not know the formulas off the top of your head, and that's okay. I'm gonna demonstrate them so that you can do them, but you could take any formulas that you know and put them in here, but this would be a fairly standard formula or fairly simple formula for a spiral. Maybe I will use a let function just to make everything easy. So we'll say x, y, z. We're going to give these all values in our let statement, and our output vector is going to be just x, y, z, the values that we've created. So just organizing everything. So x. So this will be the radius times, actually, I forgot, I'm probably going to need another value. So an extra iterator in here. It is equal to I over steps minus 1. So this is this value I. So we have this value I, and that goes from 0 to steps minus 1, but we actually want this other iterator I, which goes from 0 to 1, because that's just going to be a little bit more convenient for us. We could include this whole thing in our function, but it's just easier to have this. So radius times the cosine of 360 times capital I. Radius times sine of 360 times capital I. And so this is a pretty standard formula. This is the parametric representation of a circle. So it just goes around, around in a circle counterclockwise as I increases. Actually, I forgot one thing. So we need one more value in here, because if it just goes from 0 to 360, because this goes from 0 to 1, 0 to 360, we would get only one rotation. So we need to add in rotations. So we multiply by rotations. Okay, cool. So now z is pretty simple. We just do height times I. So these are all the functions for the values. So essentially what's happening is we've got this circle that we're going around several times, and we just increment our height, and at the beginning we want, so when this is 0, we want z to be 0. We're starting essentially on the xy plane, and then by the time I gets to 1, we want to reach our maximum height, which is the height that has been assigned. So we've got this function, great. Nothing's happening yet, so we actually have to use it. So if we want to use it, we can make a for loop, and we can say point is equal to spiral, because this is going to output a list, so we can use it this way. We want a height, let's give it a height of 10. The height is equal to 10, the radius is equal to 4, so it's going to have a diameter of 8, and the radius is 4. We want maybe, let's say, 5 rotations, and let's give it 300 steps. So now we have this, and we actually need to visualize it. So this is going to output a vector, and the vector, like, it's going to output essentially a list of vectors, and point is going to get assigned to this vector. So we essentially want to move some things that we can see around. So we'll say translate point, and we'll just take a cube because it's simple. And that should be fairly straightforward. Okay, and here is our spiral that has suddenly appeared on the screen. Magnificent. So I have no idea. Does it have 5 rotations? So we got 1, 2, 3, 4, 5. Yes, we've got 5 rotations. Awesome. And 300 of these. I mean, it looks like there are 300. Maybe if I took this down. If I took this down to like 8 and 1 rotation, maybe you'd be able to see that. Okay, so yeah, 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So we've got 8 points there. But yeah, it's not very useful for seeing things. So we bump that up to 1,000. That becomes much more like a line, and is pretty interesting. It's useful. So if I change this to 7 rotations, yeah, and you have like a coil and a spring, and now you can do what you want with these points essentially. So that is useful. And you can change these functions, of course. Like let's say we said 2 times the radius, it'll give you more of like an oval shape. Yeah, you can play with it however you like. The next example is a pretty cool way to play with these things, I think. So I'm just going to comment this out so that it doesn't interfere. Nope. There we go. Okay, and the spiral is gone because we're going to do something else. We are going to create a trefoil knot. Or I guess a PQ knot, a torus knot, whatever they are. They're interesting. They're cool looking. We'll see them in a second. And we're going to create one with list comprehensions. So if you want to know about torus knots and you want to see where I got these equations, they don't exactly look like this, but they are essentially this. So if you want to see where I got these functions and how I made them, because they're just listed on the website, and you can get the equations from there. I'm going to use them to create these knots and stuff and interesting looking shapes. So we'll take a hint from sort of what we did over here. We had this function that created a list comprehension. So we'll call this P and Q, and we want a list comprehension. Okay, so take that out. Oh, and of course we need the number of steps as well. So we get all the steps. In this case, so we have our for loop. We're actually, because it comes around pretty much the whole way, what we're actually going to do, no, sorry, that's not a for statement. This is a let statement. Capital I is going to be I over steps, as opposed to steps minus 1, because it comes back, knots come back around in a loop, and if we go over it again, we're actually doing the starting position twice, which we might want in some circumstances, but in this part, it's not necessary. So we've got that, and let's just, so we can actually, it needs to be 360 just for this to work, because t in this case, we expect t to, go around multiple times. We don't expect it to go around multiple times. We expect it to be go from 0 to 360, because in OpenSCAD, the cosine and sine functions and the trigonometric functions essentially work on degrees as opposed to radians or from 0 to 1 or anything like that. So we want our iterator to be 360 times I divided by steps. So that's what it is. Okay, so we have our x value and our y value and our z value. So we put I in the start, and actually they're all the same. So we have P and Q. And this will give us our knot, essentially. The real heavy lifting is done here by the functions, and just knowing the functions, because you could, this is so generic that, like, you could just swap this out for pretty much anything. It's any functions that you can come up with or that are useful, you can just swap them in and out and make a list of them. And that's why list comprehensions are pretty useful and powerful. So let's do essentially what we had before. Let's make a for loop. We'll say point is equal to not. We need to pick values here. So let's say, I believe the trefoil knot is 2 and 3. And so we'll say, let's have 300 values. 300 steps. So translate point. And there we go. There is our trefoil knot. And it like goes around. Cool stuff. So now if we change these values because of the functions, we get different things. And we can, like, get interesting looking things, and we can sort of see the outline of the underlying torus here. Yeah. So if we take this back to a trefoil knot, I think I'm just gonna make this look kind of interesting. So instead of a cube, we'll use a cylinder. Can't see what I'm doing there. Setting the radius, the first radius, the second radius, the height, the centers. The center is false, which means the base of the cone or cylinder lies on the XY plane, and then the FN value, which is kind of like the number of parts, number of triangles, and that it's made out of. It's related to that. Don't think it's exactly that. Say 20. And it's not happy because I didn't put a semicolon. And that is interesting and not what I'm going for at all. What does that even look like? Okay, so yeah. So let's say R1 is equal to 0.025. Yeah, like I'll probably do maybe 0.3. And height. Yeah, that's probably fine. I think honestly maybe even making them a little bit bigger. Yeah, that'll do. I think that's probably a good size. And so yeah. But they're all pointing up, so that's a little boring. So we're gonna rotate them, and we are going to use a random vector. And that is a special built-in function in OpenSCAD, which generates random numbers. So it takes a minimum value. And then, okay, so it's good that it shows it here. It's also in the documentation. It takes a minimum value, then a maximum value, and then the number of values. So it actually returns a vector, as it says here. It returns a vector. So we're going to have a minimum value, a maximum value, and the number, which in our case is going to be 3 because our rotation vector has 3 numbers in it. And then we can add also something called a seed, which we're going to use just to make sure everything is random. So we have the minimum value, the maximum value is 360. The number of results, we want 3 because we want a vector of size 3. And then our seed will be a value. In point, we'll take the x value of our point. And that should give us a good seed value. So now we get all these random rotations. It kind of looks like barbed wire. And we're going to do the same thing. But we'll go 0 to 256. Again, we want 3. And we want a seed value of point. Why don't we take the y value? So 1. And that should give us color, but it doesn't give us color. Probably because I need, let's take that, put that over there. Oh, it is not happy. No, that's because I made another mistake because it's giving us values between 256, 0 and 256, and OpenSCAD wants values between 0 and 1. So we just divide by 256, and that will, it did make it happy. Yeah, there we go. So now we've got our colorful spiky barbed wire. And I don't know, 300 of them doesn't seem like enough to me. So let's do 1,000. So we've got 1,000 little spiky things, and we have our knot that we can change. So yeah, now we've got a spiky knot, and that's what you can do with list comprehensions. Yeah, and that is pretty much everything that I have for this video, unless I think of something in the next few seconds. But the, you know, the spiky barbed wire knot is like, you know, peak list comprehension. So, yeah, I think that does it. And now you know how to do it too. So you can make the spiky list comprehension knot spiral thing. Yeah. And that's that is everything. So thanks for watching, and hopefully I'll see you in the next one.